Hey guys, so today for you I have Leetcode problem 148, which is a sorting question. So in this question you're given a linked list and you're asked to sort it in n log n time using constant space complexity. So the first thing you should be thinking is what kind of sorting algorithms you are n log n. And you should have it down to quick sort, heap sort, and merge sort. Now it says constant space complexity, so that kind of gets rid of heap sort. So you should be thinking about quick sort and merge sort. So ordinarily, quick sort is usually quicker than merge sort, but with a linked list, it's a little bit different. So in merge sort, usually you need big O of n storage to store all of the indexes, all of the elements that you're kind of sorting. So like for example, you have your array, you have your left half and you have your right half, and they're both sorted. To merge them, you have to create an extra array to store those before you put everything back into your original array sorted. But in a linked list, it's a little bit different. So if we had the 1, 3, 5 and the 2, 4, 6, they're both sorted, we don't have to store another copy of everything. What we can do is we can just move this 1 to point to the 2, have the 2 point to the 3 point to the 4, and so on. So you only need big O of 1 storage for merge sort of a linked list. Whereas quick sort, you usually use it for an array because it's only big O of 1 for a regular array of storage. You don't need to store an extra copy of everything. You're just swapping elements all the time and returning your pivot. But in a linked list, to find your pivot, which is usually the last element in the area you're sorting, it would take big O of n to find it because it's the last element, so you'd have to go all the way through your linked list. So merge sort's probably a better choice. So if you should know merge sort if you're watching this video. You sort the left half, you sort the right half, and then you merge them too. So what I'm gonna talk about first how you find a left half and a right half, and then how you merge them. So what you want to do is change this real quickly. So what you want to do is you want to take your list, which I have right here, and you're going to have a leader variable and a follower variable. And your leader variable is going to move 2 every time, and your follow variable is going to move 1 every time. So what's going to happen is your leader variable, it's going to say, okay, is there room for me to move 2 spaces over? And if there is, then you move 2 spaces over, and then your follower variable will just move 1 variable over. And this is also a way of how you can find the middle element in your linked list. So then you can say, okay, can my leader variable still move 2? Yes, it can. So I'll move this over 2, and then I'll move my follower variable over 1. So follower. And then it'll say, okay, follower should only move 1. And then it'll say, okay, can my leader variable move 2? No, it can't. So you take your follower variable and you create, then you're going to say your right. The right half is equal to follower dot right, or the follower dot next. So your right half is going to be the element after follower once it stops, once this while loop stops. So your right is going to become this. Your left is the same. Your left is going to be your original. So you could originally just set your first node equal to left. So your left is going to be this. Sorry about that. This is going to be left. And then, so your right's going to be follower.next, and then you're going to say follower.next equals null. So then that'll get rid of this kind of chain here. And then And then you have your left and your right half. So then you can return your right half, because when you have a list, you don't really have to find your left half, you just have to find your right half. So you could put that into a function and have it return your right. So that's how you split them in two. And you're going to want to keep doing that until you have elements of only size 1. So I'm going to show you. So you'd split them in half. You'd say, okay, sort this left half, sort the right half, and then merge them. So I'm going to assume that you sorted them correctly, and I'm going to show you how to merge them. Merging them, it's kind of the same no matter how many variables you have. So you have your left half. Whoops. Sorry about that. You have your left half and you have your right half. And you're going to have two other variables that you're going to use, your new list and your return value, or ret val. So the first thing you want to do is you want to compare the left element's value and the right element's value. So whichever one is smaller is going to be your first value in this, your new linked list. So in this case, our left is smaller. So we know whatever element is at the left is going to be the head of our whole list. So we're gonna put that, we're gonna set ret val equal to that value. So since we know this is going to be the first element in our return, we can just say, okay, we have to return the head, so we'll return this value. And then you can say left equals left.next, because, well, we know this is the first value. We don't really have to check this anymore. So we can just say our next element in our left side of the list is here. And we also want to create kind of our new list when we just to kind of keep track of where we are in our list. So like we would say this is our new list, and then we know that since like this is our new list, we'll be adding everything from the end of our new list. So then you want to keep comparing the left and the right side. So now we compare the left and the right. We say, okay, the right is smaller. So our new list dot next is going to be equal to right. So what's going to happen is this arrow right here, this arrow is now going to be pointing to the 2. So we've got that now. Sorry, a little OCD. Gonna kill me the rest of the video. But so we're gonna say the smaller one equals our new list dot next, and then we want to move our new list. So we're gonna say new list equals new list dot next. So we know where we can increment now. So now we know like the next smallest element will be equal to, we'll put like new list dot next equal to this next smallest element. And since we don't want to look at this 2 element ever again, we're going to move our right equal to right dot next. So our right will come here. So we're going to kind of repeat this process. So we're going to compare our left and right. We see our left is smaller, so we're going to say new list dot next equals left because it's smaller. So put a little arrow. Go in there. And then we'll say new list equals new list dot next again, because we want to know where we increment what comes, like where to put our next smallest value in our list. So we'll put our new list here, and then we'll say our left equals left dot next, because we don't want to look at this 4 element again when we're comparing the next 2 smallest values. So we'll say left equals left dot next. And then we'll kind of do the same thing. So now we'll compare our left and our right. We see our right is smaller. So we'll say new list dot next equals right. So we'll say now our new list will point, oops, make this a little bit bigger. That wasn't better. That's too big. There we go. So our new list.next will now equal the smaller of left and right. So now we point there. And we'll say right equals right dot, or yeah, so we want to increment our new list, and we'll say new list equals new list dot next. So our new list will come over here, and then we want to increment our right. Our right equals right dot next. So our right dot next is null. So we'll just put this over here. All right equals null. So our right is null. So since our right is null, we know everything else, the smallest element, is just going to be in the left. So we can just, we originally had a while loop while left is not null and right is not null. So then after that while loop kind of breaks, now that one of them is null, we could have a loop that says while right is not null, and then add everything to right, or add everything from right to our new list, and then while left is not null. And in this case, since our right is null, that the first while loop will never get executed, but our second while loop, the while left is not null, will get executed. So it'll just keep adding everything from left. So it'll say like while left is not null, new list dot next equals left. So this will point here, and then it'll say new list equals new list dot next. So our new list will move over here, and then it'll say left equals left dot next. So now left will equal null. So now our right and left are both null. And after that, we can return our ret val, which will be the head of the list. So as you can see, the 1's pointing to the 2, the 2's pointing to the 4, the 4 is pointing to the 6, and the 6 is pointing to the 8. And that is how it should be sorted. This works in nlog_n time. Show you guys my code here. So I keep track of the left half, I find the right half, and then I sort the left half, sort the right half, and then merge the left half and the right half. And I can figure out if I only have one element in my linked list, because you want to keep doing that until you have one element left. You're going to want to keep splitting them in half until you have one element left. And you can just check if the head.next is null. That'll mean you have one element left. So I'll show you my merge function. So I create a real list variable and a ret val. So the real list is kind of the same thing, as my new list variable I had there. So first I check the left variable and the left value and the right value, and that's just so I know what my head is going to be, where to put my my return value, so I know like you can you know you're either going to have to return this 1 or this 2. One of them is going to have to be the smallest in the list. So I just do a quick check so I know which one to do that for. And then I check while left is not null and right is not null. And then I compare the values. If the left is smaller, I say my list. I do make it a little bit complicated here, but I say my real list dot next equals left, and then real list equals real list dot next, which is equal to left. So I'm basically just setting so what I did here, what I would have done there is I would say, like, if this is my new list, I would have said like my new list dot next equals wherever it's pointing to. So like my new list would point somewhere, and then I say now set new list to wherever I'm pointing. So like now my new list would be here, and I just basically put 2 steps into one there. Now my dog is barking, I apologize. And then I do the same thing if the right is less than the left, And then I just say, well, left is not null, while right is not null. Check, do kind of the same thing I did here, just because I don't really have to check to compare the two, because I know one of the lists we're merging is empty, so I can just put everything else in. So, and then I just return my return value, which was the first element in the list. So if I submit this solution, you can see my runtime. Just make sure it's nlog n. If it isn't, it might not finish. And you can see beat 93.79% of everyone else. So it's pretty good. I hope you guys enjoyed. I'll make sure to link everything in the description. So thank you for watching.